Hello everyone, welcome to our channel OnlyPhysics JEE Grad. Let's continue our series of solving JEE Advanced PYQs. Today's video will be based on kinematics. The topics we'll be discussing are relative velocity, 1D and 2D. The next topic will be motion in plane, but not the projectile. There will be 7 questions. And the last topic will be projectile motion. There are total 11 questions, but only 4 we are discussing today. Okay, so let's start with our first topic, which is relative velocity. So first question will be this, right? So this is our first question. It is, a river boat problem, right? What is this question? A boat which has a speed of 5 km per hour in still water crosses a river of width 1 kilometer, okay, along the shortest possible path. So shortest possible to move in a shortest possible path, the man should be or the boat should be moving in this direction. Yes, why? This must be velocity of boat with respect to water, right? Why is that? Because boat should be moving in a shortest possible path. So this is our shortest possible path, right? This is our shortest possible path. So how it will come here? The river or the water will bring it here, right? So if the boat is moving in this direction with respect to water, then water will bring it here and this part. So the actual motion which we will be seeing from outside or from the ground is this. So this will be velocity of boat with respect to ground. Okay. Yes, perfect. So there are some information which is given. This is 1 kilometer and we have given velocity of water with respect to ground is what? Oh, it is not given. This is what we have to find. Okay, so time is given. It is taking 15 minutes. It is taking 15 minutes. Now, if I convert it in hours, so it will be 15 by 60 hours. It will be 1 by 4 hour. Okay. Now, what is given? We have another information. The boat is moving with a speed of 5 km per hour. So this will be velocity of boat with respect to water. Okay. In still water is given, right? So it will be boat with respect to water. So this is 5 km per hour. Perfect. Now, how will be solving this question? Look, this is clear that this is a vector, and finally this will be the vector. So what we can write here is velocity of boat with respect to water plus velocity of water with respect to ground will be velocity of boat with respect to ground, right? Look, if I get this information, because this is already known, this is known. If I get this, we'll find this, right? This is what we have known. If we find this, we will get this, right? So let's find velocity of b with respect to. So if I'm going to find this velocity, so the distance or displacement should be taken in same direction. It is given already. So velocity of boat with respect to ground will be distance traveled divided by time it is taking. So distance will be 1 kilometer and time is 1 by 4 hour. So it will come out to be 4 kilometer per hour, right? Okay, so this is very easy. Why? This is actually a right angle triangle. So we can directly use Pythagoras here. So how you will use Pythagoras? Yes. So it will be velocity of bg square plus velocity of wg square will be equal to velocity of bw square. Let's put all those values. So this is what? 4, right? This is what we have to find. This is 5. So it's clearly 3 will be the answer, right? So you can use Pythagoras, or I'm directly writing the answer. It will be 3 kilometer per hour. Yes, these are triplets, right? Pythagorean triplets, 3, 4, 5. So it will be 3. Let's move on to our next question, shall we? Second question. Okay, so another riverboat problem we have. This time it's a man, not the, river. Okay, let's study. We have a river flowing from west to east. So let me put the directions first. This is east, this is west, this is north, and this is south. So west to east. This is our water flowing in the a river flowing in this direction. So we have here velocity of a river with respect to ground is 5 meter per minute. Perfect. A man on the south bank, a man is here capable of swimming 10 meter per minute in still water. So that is his capability. Means it will be velocity of man with respect to river itself. How much? It will be 10 meter per minute. Wants to swim across the river in shortest time. So how should he move so that it will take shortest time? So it should be moving in this direction. So swimmer, if swimmer, right? If man with respect to river is flowing in this direction. So if you swim in this direction, you will definitely reach here, right? You will reach here, but it will be taking shortest time. You will be taking shortest time. Okay, right? So how should I swim, or how should a swimmer swim? It should be swimming in this direction, right? So he should be swimming due north. That is a extremely easy question, right? And the question we have studied just before, question we have studied just before, it's also easy, right? So on these two concepts, the shortest possible path and shortest possible time, there are two questions which were there in JEE Advanced. So this concept is very important. Okay, let's move on to our third question. This is our third question right here. Okay, perfect. So a person of height 1.6 meter is walking away from a lamp post. So I'm getting this question. Yeah, you must be getting. You have solved this question in 9th, 10th trigonometry. Yeah, application of trigonometry. These shadows question over there. Hmm? So this man's height is 1.6 meter. Okay, and this lamppost is 4 meter. Perfect. Flat ground, the lamppost and the person are always perpendicular to the ground. Perfect. If the speed of the person is 6 centimeter per second. Okay. Let's suppose this is y. Let's suppose this is y. So the person's feet is moving in this direction with the speed 60 centimeter per second. So 60 centimeter per second is changing y. So it must be dy by dt must be 60 centimeter per second. So what can I write? This is velocity of person. I say it's a p with respect to g, right? With respect to ground. Perfect. Now, next we have given the speed of the tip of the person. Okay, this we have to find. I think the speed of tip of the person's shadow on the ground with respect to the person. Okay, we think it's complicated, but I think it's easy one. So look, if I make like this, so lamppost will be applying shadow here. So this person's shadow should look like this. This is his head, and these are its feet, right? It should look like this. Now, look, this is a point on head, and I say this distance is x from feet of the person to the head of the person. This is actually x is what? X is what? I am writing it here. X is what? Height of person's shadow, right? Height of the person's shadow. And look, when this reach here, when this reach here, right? So shadow will be casting like this. Okay. So this becomes the shadow of the person. Okay, so actually x is also changing. Uh, So height of the person shadow is changing. Look. So actually, what is this x plus y? If I write x plus y, what is that? This is actually the shadow's head from this point. I say this is O, right? And if I differentiate it with respect to time, what will it give? It will give us velocity of shadow, right? Head or shadow, you can say anything, with respect to ground, with respect to ground. So what we have, we need to find velocity of shadow with respect to person. So what will write? Velocity of shadow with respect to ground minus velocity of person with respect to ground. Simple as that, right? So what is the velocity of shadow with respect to ground? It will be d by dt x plus y minus, what is this? It is dy by, right? So all are in this direction. I'm taking this as positive x. So that is why I've written like this. So it will be simply dx by dt. So this we need to find, right? That's all our question. So this is a small triangle. This is a big triangle. So let's say this is theta. So tan theta will be 1.6 divided by x will be equals to 4 divided by x plus y, right? Let's cross multiply each other, uh, them from this and this. We will get 1.6 x plus y equals to 4x, right? So if I differentiate it, or let's first rearrange them, so it will be 1.6x plus 1.6y equal to 4x. So we will get 1.6y will be equals to 2.4x, right? Let's differentiate. So it will be 1.6 dy by dt will be equal to 2.4 dx by dt. Yeah, we'll get the answer, right? So this we will divide it, and dy by dt we know it is 60 centimeter per second, so it will be 1.6 into 60 divided by 2.4 dy by dt, right? So from decimal to decimal it will cancel, it will be 2 divided by 3, and this will be 20, so we'll get dx, sorry, this was dx by dt, so dx by dt will get how much? 40 centimeter per second, right? So this will be our answer. Okay, so again it was an easy question, but you have to be very careful here, right? So height of the person's shadow is moving, or person or shadow itself moving are the same thing, right? Next, let's move on to fourth question, shall we? So this is our fourth question. Okay, so in this question, it is given a rocket is moving in a gravity-free space with an acceleration this. The length of the chamber inside the rocket is 4 meters. Okay. A ball is thrown from left hand of the chamber in positive x direction with this speed. So this ball is thrown in this direction with positive 0.3 relative to rocket. Okay. And at the same time, another ball is thrown in minus x direction. This. Okay. From its right hand related to the rocket, the time in seconds when the two balls hit each other is okay. So look, this is our rocket. It is moving with an acceleration. This ball is thrown in this direction and this ball is thrown in this direction, and they will meet somewhere, right? So how will solve? Let's move on to let's move on in the frame of a rocket itself. Okay. So if I move in the rocket itself, the rocket must be must stop. So this a I have to like relative concept. What we were doing when we come in a frame of reference which is moving with some acceleration, then all other particle on the other particle we have to show acceleration in opposite direction, right? So if I show acceleration opposite to it, it will get cancelled. So this comes in rest, right? Why it is in rest? Because we are studying situation in frame of rocket itself, right? So this is how we were studying this. Now look here, as soon as we are throwing this particle here, it detaches itself from the rocket, right? So there will be no acceleration on it, I have to show, right? Similarly, this, when we throw this B particle with 0.2 meter per second, now it is moving in a space. So the acceleration of a rocket does not make any difference here. So simply this is moving with a 0.3 meter per second and this is moving in 0.2 meter per second, right? Let's suppose this is this a particle is traveling x distance and this will travel 4 minus x distance, and they met at single point. So let's calculate the time taken by a, which will be equal to time taken by b. Time taken by a will be, yes, it will be x divided by 0.3, and time taken by b will be 4 minus x divided by 0.2. So if we rearrange them, so this will be 2x equals to 3, 4 minus x, right? So what it will be? It will be 2x equals to 12 minus 3x. So 5x will be 12. X will be 12 by 5. We get x. We can find time. So time will be x is what, 12 by 5 divided by 0.3. Yes. So it will be 12 by 5 into 3 into 10. So it's 2. It's 4. We'll get 8 seconds. So this is an easy question, but it is a bit tricky one. Okay, so it's a tricky one, right? Next, we will be studying questions. They were the 4 questions based on the topic relative velocity. Now we will be going to a second topic, which is motion in plane. Okay, there will be 7 questions which we'll be discussing. So let's move on to our, this was fourth, right? So let's move on to our fifth question. Okay, this is our fifth question. Now, a particle P is sliding down a frictionless hemisphere ball. It passes A at time t equal to 0 at an instant instead of time. Okay, the horizontal component of velocity is a v. Okay, so look, this is our hemispherical ball, and we don't know where it is coming, but when it comes to A, this P particles, it has some downward velocity, we call it Vy, but it has a this velocity which we call V. Okay, and then it is moving in a this hemispherical ball like this, okay. Now at the same instant equal to 0, another particle must be here, this bead Q, the same mass P is ejected from A at equal to 0 along the horizontal AB. Okay, so this is B. So this particle is moving like this. This particle we call it Q. This particle we call it P. Okay, with this speed V. Okay, so speed is this. A's particle, the speed in this direction is V, and Q's particle in this direction is V. But the speed of the particle in Y direction is Vy, which we don't know, right? The direction friction is neglected. Okay, TP and TQ are the time when they reach B point, right? So look, the first moment, the first thing which will come in your mind is that in the horizontal direction there is no acceleration, right? So we'll say, so in the horizontal direction displacement is 2r, acceleration is 0, velocity will remain v. So Tp must be equal to Tq, and you will take P. But this is wrong. This option is wrong. Why? And the bead, suppose it is here, right? Let's make the freebird diagram. Mg is downward, normal is here. So in the horizontal direction, there will be component called n cos theta, right? So acceleration in x direction is not zero. It is not zero. There will be some acceleration, right? Okay, perfect. Let's solve it. Okay, look, if I start to solve using force equation, right? Or work equation, energy conservation, right? I won't be able to solve it. Why? Because the acceleration is always changing. So acceleration is not zero, right? But acceleration in x or acceleration in y direction is always changing. So this is a very typical question. Won't be able to solve like this, right? Uh, So I have to study this question not quantitatively but qualitatively or analytically. So let's study this question qualitatively. Okay, now look, when this p particle is here and it will reach here, one thing is clear, at the most bottom point, the particle velocity will be in this direction only. Let's say it is v dash. Now, if I use energy conservation at A and C, what we will get? At A, it will be half mv square plus half mvy square, right? Let's say use 0 here is equals to, at C, it will be minus mgr plus half mv dash square. So if I write half mv dash square, it will be half mv square plus vy square plus mgr, right? Now look, clearly v dash is much greater than v. So what is happening is, as particle is moving down, this horizontal velocity is increasing, right? So when q reaches the center of the bowl, a have already reached in here. A have already reached it. Why? Because this horizontal velocity is increasing. So displacement of both particle here is r, right? Displacement of both particle is r. This is also r, right? The velocity of q in this direction is always v, yeah. But velocity of particle p in this direction is always increasing. So velocity of a particle in x direction is increasing for the path A to C. Yeah. So a p particle will take less time to reach at C, right? Now, at C, the horizontal velocity is already greater than v. Yes. And as soon as it will reach B, if I use energy conservation here again, let's use energy conservation for C and B, right? So this was energy conservation for A and C. Now let's use energy conservation for C and B. Okay, what we'll get? It will be half mv dash square equals to, yes, okay, minus mgh will also be there, right, at C. Now what will we get? Half, let's say at here the particle's horizontal velocity is vx and vertical velocity will be vy. Yes, so vertical velocity we don't know, so it's v dash and vx dash, right? So let's put it here, will be half m vx dash square plus half m vy dash square, right? So if I put half m this, if you put this equation here, you will get half m v square plus vy square will be equal to half m vx square plus half m vy square, right? So if you like rearrange them, you will get vx dash will be equals to v and vy dash will be equals to vy, right? So at this point, at b point, so you will get at b point the particle velocity of p particle in horizontal direction will be v, and in the vertical direction it will be vy again. So it started from vy here, it moves to vx v here. Now the velocity is increasing in the horizontal direction, then in the horizontal direction velocity is decreasing again, right? But what is happening is for the other half, here velocity is more, right? V dash. For other half, the velocity is decreasing such that the at the end velocity becomes v. So for A to C, velocity of particle p in x direction is always greater than v, and similarly for C to B, even though velocity is decreasing, but velocity of p in x direction is still greater than v. Yes, at p it becomes v, so it is still greater than v, right? That implies both have same displacement, both p and q have same displacement in x, but the speed of p at all the times in x direction is always greater than speed of q in x for for all the time, for all the time. That means time taken by p to reach p must be less than time taken by yes. So that is how we'll get our answer. Okay. So this question is not based on, of course, mathematically we cannot find anything, but by using some basic concepts like energy conservation, we can reach to the conclusion that time taken by p must be less than time taken by q, right? So we, even though this question has no mathematics here, very less mathematics here, but still qualitatively it is a tough question. So I must consider it as a hard question. Okay, now let's move on to our sixth question. Sixth question, let's move on. Okay, so here we have our next question of motion in plane. Okay, so this question is again bit hard because there are lot of things in it. Okay, let's so starting at time t equal to 0 from origin with the speed of 1 meter per second. Okay, so it is starting at t equal to 0, x 0, y 0. So at t equals to 0, x is 0, y is 0, and the velocity of the particle, its net velocity is 1 meter per second. Perfect. Particle is moving in a two-dimensional trajectory of this equation this. So if I make y versus x, so particle is moving like this, right? So trajectory. So first, this is our situation. Second thing is given y equal to x square by 2. Okay. The x and y component of velocity, this is okay. So first, we have to choose these options. There may be all correct, one correct, or two, three, right? So this question was there in advanced 2020. It's a nice question. It's a pretty hard. Let's find the acceleration first. So let's differentiate it to both. So we will get dy by dt will be equal to 2 divided by 2x dx by dt divided by 2. So 2 will cancel. What is dx by dt? Right. What is dy by dt? It is velocity in y direction is equals to x, velocity in x direction, right? So this we call it as our first equation. Next, what we have here is, let's differentiate it again. So we'll get dy by dt, dvy by dt equal to first this. So it will be dx by dt into vx plus x d vx by dt. So what is that? This is just this is product rule I have used here. So we'll get ay will be equals to dx by dt is vx, so it will be vx square plus x ax. Okay, so this is our second equation. So without looking at the option, first let's draw some conclusion here. At t equal to 0, it is at x equal to 0, at y equal to 0, and v is 1. So look, at x equal to 0, at x equals to 0, vy must be 0. And if vy is 0, then only the velocity left here is this. So it must be vx. Okay, so it must be vx equals to 1 meter per second. Okay, at t equal to 0. Now, similarly, I should write it as t equals to 0. Similarly, the next conclusion we can find here, at t equal to 0, x is 0, right? It is always true. So ay must be equal to 1. So at t equal to 0, x is 0, so ay must be 1 meter per second square. This is true. This is always, no matter what the thing is given, this will be always be there, right? Okay, perfect. Let's move on to our parts. Okay, let's move on to our first part. Let's move on to first. Then ax is 1 meter per second square implies that particle is at origin and ay is this. So we have to write this it's like a condition given and we have to solve for this. Perfect. So it is given if ax is 1 meter per second square, it implies that when particle is at origin, so when particle is at origin, ay is 1, because at t equal to 0 particle is at origin itself, so ay is always 1. So this option is correct. Even though this is happening or not, ay still comes out to be 1 meter per second square, no matter what. Perfect. Second. So A is correct. If ax is 0, implies ay equal to 1 meter per second at all times. Okay. So ay 1 meter per second is only true for this. We do not know about other things. It's not always, it is always, I should write, it is always true for t equal to 0. Not for all the time, right? It is saying all the time. So I have to use this condition. So let ax equals to 0. So if I put ax equal to 0, ay turns out to be vx square, right? Now we have to find vx. Okay, so this is like our third equation. Okay, ax is always 0. Ax is always 0. That means x is always 0. That means velocity in x direction is constant. Are you getting me? Velocity in x direction is always a constant. Velocity in x direction is always constant and it is starting with v meter per second. So vx equal to 1 meter per second always. Yeah, I should write here all the time for all t. If vx equal to 1 meter per second for all t, that means ax must be equal to 1 meter per second square for all t, given ax must be 0. Are you getting me? Are you getting me? Again, let me tell you. Question in the B part, it is given ax equal to 0. So if ax is 0 for all the time, that means velocity in x direction. Ax is what? Acceleration in x direction is 0. That means velocity in x direction must be constant. Velocity in x direction is constant, and we know at t equal to 0 it is starting with v 1 meter per second. That means velocity in x must be 1 meter per second for all the time. If this is 1 meter per second for all the time, and we have this equation we put here, ax will come out to be 1 meter per second square. It is constant for all t. Yes, so this option is also correct. Okay, let's move on to our, so look, this is why I'm saying it is a hard question. There are a lot of conditions, lot of equations which we have to deal with, and we have to find the answer. So question in the third part, it is given at t equal to 0. Okay, we know already the particle velocity points in x direction. Yes, yes, because vy is 0. So C option is correct. If ax equal to 0 implies, okay, ax equal to 0 implies that at t equal to 1 second, the angle between the particle velocity and x-axis is 45 degrees. Angle between the particle velocity and x-axis. Okay, so look, ax equals to 0. It is not saying at all the time, right? At t equal to 1, it is specifically saying. Okay, so t equal to 1, ax is 0. That means at t equal to 1, ay is what? 1 meter per second square, right? Okay, I have to take in between. I don't know what is happening, but I have to take for all the time. Okay, so ax equal to 0 for all the time I have to take, right? Ay is what? 1 meter per second square. Now, let's solve for both x and y, right? So x equal to 0, so velocity in x is always 1 meter per second, no matter what. Velocity in y, as a is constant, ay is constant, we can use three equation. So we'll get a vy equal to uy plus ay t, right? So vy is what we have to find? Uy is 0 plus ay is 1 into 1. So we'll get vy as a 1 meter per second. Now, if vx and vy is same, that means they must be making, this is vx 1 meter per second, and this is vy 1 meter per second. So the resultant of net velocity must be making 45 degree with the x-axis. So this option is also true. So answer is actually A, B, C, D. A, B, C, D is our answer. Are you getting me? Please study this answer solution, which I have told 2-3 times. You will get to know everything. So look, many things we have to check. That is why I have put this question under, like, hard. It's a hard. That is why it is a hard question. Perfect. Let's move on to our seventh question. Yes, seventh question is this, right? This is our seventh question. Okay, perfect. Now, this is quite interesting question. We have given a particle is moving in x such that a cos pt, okay, and it is moving in y direction as b sin pt. Perfect. A, so b is less than a. Mhm. B is less than a. No issues. Okay, now we have to check all these points again. First, the path of particle is eclipse. So I can write x by a equal to cos pt and y by b equal to sin pt, right? Now let's square these terms and add them. So we'll get x square by a square plus y square by b square will be 1 because sine square theta plus cos square theta will be 1. And this is the equation of ellipse. This is the equation of ellipse, right? So this is true. Okay, so first part is true. The path of the particle is an ellipse. Next, velocity and acceleration of the particle are normal to each other. Okay, so let's find the velocity. So we can get Vx as AP minus, just differentiating here. Okay, so we will get minus AP sine PT, and we'll get Vy as BP cos PT, right? We can write AX as minus AP square cos PT, and here we can write AY as BP square minus sine PT. Okay, now so we have V vector as minus AP, so minus, okay, so simply I can just take P as common. We'll get minus A sine PT I cap plus B cos PT J cap, and here we will get acceleration as P square, I can take common, right? Minus A cos PT I cap plus, yes, okay, minus again minus B sine PT, okay, J cap. So if they're perpendicular, then A dot P must be 0. Let's solve it. So I into I will be A square sine PT cos PT minus, this is minus minus plus, this is plus minus minus, P square cos PT sine PT, which is not necessarily 0, which is not 0 because A and B are different. So this option is wrong, right? So this option is a wrong. Next, C part. In the C part, we have given what we have to find: acceleration of particle always directed towards the focus, right? I will get. So look, this point we do not need to solve. Why? Okay, wait. At t equal to pi by 2p. So pi by 2p we have to find, right? Pi by 2p we have to find. I'm sorry. So let's just put time as pi by 2p. So as you put pi by 2p, this will become 0 and this will become 0. So it will be 0 at, let me write it, pi by 2p, right? At time pi by 2p. So yes, this is correct. This option is correct. I'm sorry. At this time we have, it is given, right? Okay. This time it is given because at this time velocity will be in x direction only and acceleration will be in y direction only, because this and this component will be 0. This component and this component will be 0. That is why. Perfect. This is correct. Now, acceleration of the particle is always directed towards the focus, right? This option is correct. You do not, you can solve it using mathematically, but clearly this particle is moving in ellipse, right? So it is like our motion of the planets, right? In the gravitation we have studied motion of the planet. So force is always directed towards the focus. So acceleration of particle is always directed toward the focus. This is correct, right? Next, the distance traveled by the particle in the time interval 0 and pi by 2p is a. So look, if particle is starting from here, right, at x equal to 0 it is starting, or y equal to, it is starting from here. right? So for half time it will move here, half time it will move here, another half here, another half here, right? It is moving like this. The distance traveled by the particle, distance it is asking, right? So we know the circumference of ellipse is what? Circumference of ellipse is what? 2 pi root a square plus b square by 2, right? Right? Now, look, if particle is starting from here at t equal to 0, why? Why it is starting from here? If you put t equal to 0, then x will be a and y will be 0. Okay, so particle is starting from here. So at t equal to 0, it is here, right? Now, in x, particle is moving as you increase x. So particle is moving in, yeah, this is a, okay, this is when you when you increase time, what you will get, right? At time pi by 2p, at time pi by 2p, this will be 0 and this will be p, so particle will be here. So particle is moving here in this direction, right? The shadow of the particle is moving in this direction, then this here, then this here, then this, right? So for half the time particle will be moving in this direction and this will be greater than a. So distance is asking, not displacement. So distance will be greater. If they are asking what will be the displacement in x, it will be a, but it is asking distance traveled, it must be greater than a, right? So this option is wrong, right? So a, b, c will be the answer. Okay, so it's a moderate question but not tough. You can use a circumference of ellipse also, but you have to use it like as a fourth of this, so you will get the exact answer. But here we do not need to use this. Okay, so this was our seventh question, right? This was our seventh question. Now let's move on to the eighth question. Eighth question, let's move on. Right. So this is our eighth question. It looks easy, no? Three lines is there, so it must be easy. You should not do like this. Read the question, make the situation, and think if you can solve it. Otherwise, just leave it. A particle is moving in eastward, so we can say this as east, west, north, south. So particle, let's say it start here and it is moving here in this direction 5 meters per second. In 10 seconds, the velocity changes. So suppose it will come here like 50 meters, the velocity changes to northward 5 meters per second, right? With the average acceleration. Okay. So we know velocity, initial velocity was 5 meter per second in x direction. So xi cap. Then the final velocity. So this was initial, this is final. Final will become 5 meter per second in y cap. Right? We know the formula of average acceleration. Yes. What it will be? Yes, v final minus v initial divided by time. This is average. So let's put here 5 meter per second j cap. Just let me write it 5. So it will be 5 j cap minus 5 those y, right, x cap divided by what? After 10 seconds it is. So 10. So it will be j cap minus x cap divided by 10. So what is this direction? First let's find this direction. Divided by 2. Hmm? So minus plus j cap. So plus j cap will be this, right? Plus j by 2 will be this and minus by 2 will be this, right? So direction of acceleration will be this, right? And the component will be same. So it will be, component are same, right? Let me write it. It will be minus 1 by 2 x cap plus 1 by 2 j cap. So x and y component are same. So it will be in this direction, which is northwest. So northwest will be the answer. And the magnitude we have to find. So magnitude will be root 1 by 2 square plus 1 by 2 square. So it will be root 1 by 4 plus 1 by 4. It will be root 1 by 2, which is 1 by root 2. So this will be the magnitude. So 1 by root 2, B option will be correct. So it's a very easy question. It's a basic. You can use a vector here also. Nothing to worry. Ninth. Let's move on to our next question. Okay, perfect. Now, airplane A and B are flying with constant velocity. They're flying with constant velocity in the same vertical plane at angle 30 degree and 60 degree. So let's say this is our plane. This is y, this is some x. And B is moving like this, right? And A is moving like this. So it's possible that they will hit each other, but we have to study the question first. Okay. Now, what is given? The speed of VA A is 100 root 3 meter per second. So I have written VA equal to 100 root 3. At time t equal to 0, an observer in A finds B at a distance 500 meter, and this observer see B moving with constant velocity perpendicular to the line of motion A. So at some point, B is directly moving towards the line of perpendicular to the line of A. So B is moving like this, right? B is moving like this. But this velocity is of P is with respect to A, because this observer was in B, right? So let's say this is B is over here. So this is path of P. I should write it as a path of P, and this was path of A. So A must be here, huh? Right? And this distance is what? 500 meter. Perfect. And this is perpendicular to this, right? So if I resolve things in this plane, if I if I resolve things in this plane, are you getting me? I resolve things in this plane. So this is velocity of B, and this is velocity of A, right? So I'm resolving it in this plane. So this is perpendicular. Uh, so this line must be like this, right? These two are parallel. So this angle is 30 degree. So this is VA, this is VB. So it will be VB cos 30 degree, and this will be VB sine 30 degree, right? So this is VB, right? So this is VB. So I should write VB here. This is VB, and this was our line. And let me make it in green, right? So this angle is 30 degree. So VB is here. This angle is 30 degree. Why? Because VA is at 30 degree and path of VB from the x-axis is 60 degree. And this line is parallel to this, and this is 30 degree. So VB must be at an angle 30 degree. Now, if I come in the plane of like if I be in the airplane A, then what will I see is B is directly moving towards us. That means velocity of A must be equal to VB cos 30. VB cos 30, right? Because it will get cancelled out, right? So parallel, there must be no velocity. So velocity of A I know is 100 root 3. Velocity of B we have to find to cos 30. Cos 30 will be root 3 by 2. So that comes out to be VB will be 200 meter per second, right? I mean, if P is moving towards A, that means velocity of P parallel to A must be same, right? And I'm resolving it in a plane of A, right? So I'm resolving it in a plane of A. So that means VBA must be equal to VA sine 30. VB sine 30. VB is 200 and sine 30 is 1 by 2. So it will turns out to be 100 meter per second. Now we have the distance and we can find just time. So time will be distance is 500 and speed is 100. So it will be 5 meter per second. This will be your answer. Right? So it's a moderate question, right? Because this you have to understand that I'm taking a plane which is the plane of A, you can see, right? So A is moving here like this. So this is like my X dash and this is like my Y dash. Okay. So in this plane, I'm resolving things and then I'm considering the velocity of like it will be as B is moving directly towards A. So velocity of B parallel to A must be 0 or must be same to VA. So VA I have written is equals to VB cos 30. That will be my answer, right? Let's move on to our 10th question. So let's move on to our 10th question. Okay, perfect. So this is our 10th question. Right. On a frictionless horizontal surface, assume B, X, and Y, a small trolley A is moving along a straight line parallel to y-axis. Okay, it's moving like this only. And the speed is given with the velocity. It's very different, root 3 minus 1 meter per second. Okay, no worries. Now, at a particular instant, when the line OA makes an angle 45 degree with the x-axis, the ball is thrown along the surface from the origin O. Its velocity make an angle 5 with the x-axis. So I don't know. It's like it. If it hits that trolley and it hits the trolley, okay. So it is moving like this. If I throw it like this, it will go like this and it will not hit, right? So I must throw it like this. Let's say this is V dash and it is making an angle phi with the x-axis, right? And it hits the trolley. It will be hit. So the situation will be like this. This is our trolley. It is moving like this. So at some point it reaches here, right? And this is our ball thrown like this. It will hit. So when it will hit, this was angle 45 and this will be fine. So it will exactly hit and the angle made by trolley is phi. So right, this angle must be phi. So origin, let's say this is A, this is B. So angle made by OB must be phi, then and only it will hit, right? Because both are thrown with a constant velocity along the surface. Okay, perfect. Okay, question is missing. Let me write the question for you. So first in A, question is the motion of the ball is observed from the frame of the trolley. So motion is observed from plane of the trolley. Okay. Calculate the angle theta made by the velocity vector of the ball the x-axis. So angle, we have to find what is the angle. What is this angle? Made by velocity vector of the ball. Velocity vector of the ball with x-axis. Right? Okay, perfect. So look, if I'm on the trolley, if I'm on the trolley, the velocity vector is like this, right? Velocity vector is like this. Now, what should I do? Yes, what should I do? Think. It's a pretty easy question, right? If I'm sitting on this trolley, what will I feel? The trolley is at rest and ball is directly coming towards me. Ball is directly coming towards me, right? If I'm sitting on the trolley and I know for a fact that this ball is going to hit me and I'm sitting on the trolley, means I will see this ball is directly traveling towards me. And initially, what was the angle? It was 45 degree. I will at all the time I will be at rest. For me, the trolley is at rest because I'm on the trolley. So ball will be what I will be seeing. The ball is directly coming towards me. So angle will be 45. So this question was easy. So angle will be what? Angle will be the theta will be 45. Next, there is another part for this question. Find the speed of the ball with respect to surface if phi is 4 theta by 3. So we have find the theta, right? So theta is 45, 4 by 3, pi by 4 I can write, right? 45 degrees for that I can write in radian, 4 by pi by 4 will cancel. So pi by 3 will be 60 degrees, right? So that means phi is 60 degree. Phi is 60 degree. Now, what we have to solve? We have to find speed of the ball, right? Speed of the ball. Okay, right. So trolley is moving. Look, so this is a velocity vector of ball with respect to trolley. This is the velocity vector of trolley with respect to ground, and this is the velocity vector of ball with respect to ground, right? Perfect. So how will you find this? That's an easy. Please take 2 seconds to answer. Right. So why don't we resolve it? Right. So this was angle 45. This was 60 degree. Right. So look, the component of velocity of p with respect to ground is this in the y direction. It will equal to vt and this. And how much is this? So this is our vbt, right? Velocity of p with respect to t. So it will be this, right? So this is velocity of pt sine 45, right? And this will be velocity of bt cos 45, right? Now look, for pg, the horizontal component should be same, right? So I can write velocity of bg cos 60 degree should be equal to velocity of bt cos 45. And for this is our first equation. And for second, we can write velocity of bg sine 60 degree. This must be equal to vtg plus this, which is vbt sine 45, right? We just need to solve this. Now vbg and vbt both are variables, so we have two equation and two unknown, we can solve it, right? So vbg by divided by 2, because cos 60 divided by 2 will be equal to vbt by root 2. So it will get cancelled and it will become root 2. So we will have vbg will be equal to root 2 vbt, right? Now, we have to find velocity of pole with respect to ground. So let us put VBT as VBG by root 2. So VBG sine 60 is root 3 by 2 is equals to V of t, trolley with respect to ground was root 3 minus 1 plus VBT, we don't know. So we can write it as VBG divided by root 2 and sine 45 will be, so it will be 2, right? Now solve here, let's solve it here. So what will it be? It will go here, right? So VBG root 3 by 2 minus 1 by 2 will be equal to root 3 minus 1. So if we take it as a common, root 3 minus 1, root 3 minus 1 will be cancelled, and we will get VBG will be 2 meter per second. Yes. So that was a nice. If you can resolve it, you can use vector and some of the components, and there are multiple ways to solve. I find this easy. So, right. So this question we can again consider it as a moderate, but it is not very easy. It is not very tough, right? Okay, shall we move on to our 11th question? Let's move on to our 11th question. Okay, so this is our 11th question. It is a fill in the blanks question. Okay, it must be easy, no? Let's see. Four person KLM and are initially at four corners of a square. So this is our diagram. Okay, here we have K, L, M, N. Okay, side is D. So this distance is D. Each person now moves with uniform velocity V in such a way that K always moves directly towards L directly towards M. Okay, perfect. So let's say here it is starting. So K is moving directly towards A with a constant speed, and this is moving here. It is moving here. It is moving. Perfect. Now, the fourth person will meet at time t. Will meet at time what? So t we have to find. Time we have to find. Look, after some time, what will happen? This O will go here, right? Just after a small time, right? So what is going to happen? This V will be chasing it. So this is moving like this. So it must be moving like this, right? So here it must be like this in this direction. This is moving like this. So this was chasing him. So it will be like this. This was chasing him. So it will be like this. And it will be like this, right? So what is happening after some more time? It will go here. It will go here. It will go here, and it will go here, right? After that, it will go here. It will be here. It will come here, and it will come, right? So you're getting me. So K will follow this path, right? L will follow this path. M will follow this path, and N will follow this, right? So their path is like this. Now look, speed is constant. Speed is constant, but velocity is not because direction is changing. Direction is changing, right? So we can clearly see velocity is not constant, right? This is velocity. So velocity is not constant. And look, the situation is very typical. I mean, you cannot solve it. Like the path is very complicated here. We do not know even how this path is. So we have to make it a like we have to first analyze the situation, right? And then resolve it to a simple situation so that we can solve, right? Now look, this question is pretty famous question. This is a famous question, and almost all the answers on in the online as solution are wrong, right? So I'm going to give you a good solution for this question, but let's first analyze it, right? Look, First look at this k. Initially k is here, L was here. They are moving, a k is moving directly towards B, right? And the distance between them is d. Now after some time, L will be here and k will be here. Sometime L will be here and k will be here. Now the distance will be distance is decreased, right? Okay. So after some time, k and L will be here. The distance is zero. And now the velocity of k is always directly towards L, and it will be same as v, right? So look, this distance is decreasing, and it is not like jumping, like from 10 meter it directly goes to 5 meter. It is not happening like this. The change is consistent. 10, then 9.9999, then 9.9998, right? It is decreasing like this, right? And how, who is decreasing? Which velocity is decreasing? The velocity of k in this direction. This velocity v is decreasing. So simple situation will become speed equals to distance divided by time, right? So in this direction, this distance is what? This distance is d, right? And in this direction, what is the speed? Speed is v, right? Not the velocity. Speed I'm talking about, right? Distance is d, speed is v, and the time is which we have to find. So time will come out to be d by v. It is as simple as that, right? Because this distance is changing by whom? This velocity of k, right? And it is changing consistently. It is not like initially it is 10 and then with the next second or next point of time it will become 5. No, the change is gradual, right? It is consistent. Perfect. And who is changing this d? This velocity, the speed of k is changing this. So simple, the time will become d by v. It is a very simple solution, and this is the correct solution. Other solution, they are assuming this distance will be d and it is moving with v velocity, so time will be d by v. That is wrong. Why you are assuming this distance as d? We don't know. Now after this, we can find the path length of this, and path length will be d. Path length will be d. Yes, but first we have solved this, then we can find this, right? But in some solution, there are a lot of solution online. Almost all are wrong. They're just, some solutions are like that. Look, this is a d by root 2, and we can take perpendicular component will be v by root 2, right? I mean, this is moving like this. So this component is v by root 2 and this component is v by root 2. So this is the displacement. This is v by root 2, velocity in this direction. And so time we can find. Why? How you can say this is the, so this solution is based on average velocity. So how do you know this is the average velocity? How do you know? We don't know, right? So they have considered this v by root 2 as average velocity, but we don't know, right? This is the average velocity. Yes, this displacement is d by root 2, but this is average velocity. It is wrong. How do you know? Right? So this solution is absolutely correct. Don't worry about it. And JEE has developed this question to be solved by this method only. Other methods are possible, but they are extremely complicated to find the path equation and then solve it. Drastic, they are dangerous. This is the solution they wanted, and you will get it. Okay. So I will consider this as a tough question. But on the other hand, if you think clearly, you will get the answer. Right? Perfect. So these are our 7 questions. Okay, we have discussed all the 7 questions of uh, motion in 2D. Right. Next, move on to our next topic, which is projectile motion. Only 4 questions we are going to discuss because video is already getting big. So let's first discuss the question. Yes, so this is our first question of projectile. Right. So it will be like what? It will be 12th, right? Yes, 12th question. So this is our 12th question. Let's solve. A projectile is fired from horizontal ground with a speed v at an angle theta. When the acceleration due to gravity is g, the range of projectile is g. If at highest point it's in its trajectory, the projectile enters a different region where the effective acceleration due to g dash is okay. Oh, so it's a very simple question, right? You can solve it. So initially, if it is thrown at angle with the speed v at an angle theta, it will be like this. So range will be this, which will be u square sine 2 theta divided by g. Right now, situation change now. It will be like this, that it is thrown with the same speed at the same angle, but at the highest point means when it covers r by 2. After that, its velocity is same, u cos theta. It will be moving like this, right? And I don't know, it may be r dash. So the initial and final range we have to equate, and we have to put in this equation, and then we also, right? Perfect. So let's find r dash. Now look, here g is g dash. So let's solve this only. R dash will solve. What is the situation? This is our h. It is thrown with the u cos theta, and it meets here. And this is our R dash. Right? So let's first find capital H. So capital H will be what? U square sine square theta by 2g. Okay. So when it will reach here, R dash will be what? So I'm finding R dash. If I've got my R dash, I will get the answer. Yes. So tell me, what will be R dash? Okay. So in this case, time of flight you can find what it will be. Yes, you should remember the formula. Yes, what will be the time of flight? In the y you can solve it like this. So you just remember the formula. It will be root 2h by g dash, because now it is g dash. Okay, perfect. So now this is 2h by d dash. So r dash will be u cos theta into this d dash. I can write. Perfect. So what it will be? U cos theta root 2. What was our h? Will be u square sine square theta divided by 2g, and g dash was there, right? So we got our r dash. Now let's equate. What will be d dash? It will be r by 2 plus r dash. So let's somehow resolve it. So these two will get cancelled, and it will be u square sine theta cos theta, u square sine theta cos theta divided by what was g dash. So g by so g into g square, and it will root g1. So it will be u square sine theta cos theta. This will be zero point 0.9 divided by g. We can divide and multiply by 2, right? So this is our r. This is not r. Uh, this is our r, right? So this is our r. Let me. This is our r. Why? Because u square sine 2 theta by g is our r. So r by 2 into this. So it will be r by 2 into 0 0.9. Right? So r dash, it was r dash, right? So let's put here r by 2 plus r by 2, 9 by 10. So it will be 19 by 10. Yes. Okay. So this is d dash, and it is equals to nd, which is nr, right? So r will get cancelled. So n is simply 19 by 20, which is 0 point something. So it will be less, right? Okay, perfect. Let me check the answer. Was it 19 by 20? Just give me a second. Yes, 0.95 it was. Okay. Let's move on to our next question. 13th question will be solving. Okay, perfect. A ball is thrown. Oh wow, it's an interesting question again. Let's see. A ball is thrown from the ground at an angle theta, horizontal initials to be not okay. For the resulting projectile motion, the magnitude of average velocity of ball up to the point where it hits the ground for the first time is v1. Okay, so for this whole motion, right, is, let's call it 1. The average velocities for part 1 is v1, capital V1. It is thrown with the unit. Okay. After hitting the ball, the rebound set in same angle theta, but the velocity is u naught by alpha. Okay. And it continues for a long time. So like t is infinite. So long time. So many bouncing is happening, right? And the average velocity for the entire duration is 0.8. So average velocity for entire motion, not just part 1, it's all will be 0.8 v1. Okay, the value of alpha is okay. So first we should know the formula for average velocity. What is the formula for average velocity? It is total displacement upon total time. Now, so for part v1, it will be range divided by time of flight, right? For other part, it will be total displacement. So for total displacement, let's say the range is r1 here, it is r2 here, it is r3 here, and time of flight for that is t1, for that is t2, for that is t3, and so on. So it will be r1 plus r2 plus so on infinite divided by t1 plus t2 plus so on infinite. And then we have to equate them, so we'll get alpha. Okay, perfect. We know r, right? So it will be r1 by t1, right? So we know r1. It will be simply u square sine 2 theta divided by g, and time of flight will be 2u sine theta by g. Right. Let's find for r2. R2 will be, the speed will be half. It will be u naught square divided by 4 because u naught by 2, and the angle is same and g is same. T2 will be 2 u naught by 2 sine theta by, okay, not 2, it's alpha, so alpha square I should write, and it will be alpha. So if I compare R2 with R1, it will be R1 by alpha square. And if I compare T2 with T1, it will be T1 by alpha, right? For next, let's just for R3, let's solve. It will be U naught. So how much it was? Let me rub it. T3 alpha square. Okay, so it will be U naught square divided by alpha square square, alpha 4 sine 2 theta divided by g, and for to find t3 it will be 2 u naught square by alpha square, u naught by alpha square sine theta divided by g. So let's compare r3 with r1. It will be r1 by alpha 4. and it will be t t1 by alpha square, right? So let's solve it. Let's on the average velocity for entire. So it is 0.8 v1 will be equals to r1 plus r2 will be r1 by alpha square plus so on divided by, okay, let's put r1 by alpha 4 plus so on, and it will be t1 plus t1 by alpha plus t1 by alpha square plus so on. This is an infinite GP. For infinite GP, we know the formula. Okay, let's just take something common. R1 by T1 we can take common. So it will be 1 plus 1 by alpha square plus 1 by alpha 4 plus so on divided by 1 plus 1 by alpha plus 1 by alpha square plus so on. It's an infinite GP, right? So for infinite GP, we know the formula. What was it? A plus AR plus AR square. So for that, it will be A divided by 1 minus R. Let's just put it. Okay, so V1 was R1 by T1. Let's put it, or let's put this one also. So 0 point, let me change the pen. So 0.8 R1 by T1 will be equal to R1 by T1. So first this GP, the first term is 1 divided by 1 minus 1 by alpha square. When this is the second, 1 upon 1 minus 1 by alpha, right? Okay. So R1 by T1 will get cancelled. So this is 0.8, and this will be alpha square will come up, will be alpha square minus 1. For that, it will be alpha upon alpha minus 1. I've just taken the LCM, okay? So this will be 0.8 equal to alpha square by alpha square minus 1 into alpha minus 1 upon alpha. Denominator will become numerator. Okay, so this will get cancelled. And for this, we can write alpha minus 1. It will be alpha minus 1 into alpha plus 1. This also get cancelled. So we will have alpha plus 1 will be 1 upon 0.8, right? So it will be 10 by 8. So 10 by 8. So we will have 8 alpha plus 8 equals to 10, right? Am I doing it correctly? I'm doing it correctly, right? Uh, yes, let me check. Alpha plus 1 will be this. How to find the alpha, right? We have 1 alpha square minus 1, and this will be alpha minus 1 real. So alpha minus will come up. Okay, the alpha is left. So alpha will get cancelled, alpha left, right? Okay, I have to, because I'm thinking that something is wrong here, right? So this is 8 by 10. You can write 8 by 10 will be alpha upon alpha plus 1. Now it is fine. So it will be 8 alpha plus 8 will be equal to 10 alpha. So it will be 8 equal to 2 alpha. So alpha will be 4. Okay, so this is our answer. So again, it's a very nice question, right? A bit a bit lengthy, but it's a good question. Next, let's move on to our 14th last second question for this video. Okay. A ball is projected from the ground at an angle 45 degree with the horizontal surface. Perfect. With the speed something you not, I don't know, 45 degree. Do like this. It will reaches a maximum height of 120. So maximum height is 140, 120, which will be u square sine square theta divided by g, right? And returns to the ground upon hitting the ground for the first time. Okay, when it hits, immediately after the bounce, the velocity makes an angle 30 degree with the horizontal. So it will be moving with some v, but the angle is less. So angle will be 30 degree. The maximum height it reaches after bound in meters. Okay, so this we have to find h dash. So h, this is h, right? This is how to find. Okay, let's first solve this. So we will get, okay, there is another information. It loses half the kinetic energy. So first let's find V naught. Yes, this is V naught. So it will be 120 into G is 10 equal to U naught square, and sine square theta 45, it will be 1 by 2. 1 by root 2 square will be 1. So we will get U naught square will be 12 into 2, 2400, right? Okay, perfect. Now what happens is the initial kinetic energy is half m v naught square, and final will be k initial by 2, right? Okay, so it will be half m. So we can find the velocity, right? Half m v naught square, it will be 2400 divided by 2, right? Perfect. So final velocity we can find, it will be half m v square. Half m will get cancelled, and the v square will be 1200. So v will be root, uh, we can write it as 10 root 12, which is 20 root 2, 20 root 3, 20 root 3 will be the answer, right? Let me rub it. So 20 root 3. Perfect. Now h dash we can find a very easy question. Yes, so h dash will be u square. So u square is 1200 into sine square theta. Sine square 30 degree will be 1 by 2, so 1 by 4 into g. So it will get cancelled. This is 30. So answer will be 30 plus. Okay. It's an easy question again. Nothing to worry about. Just write the formulas, write the situation, and you will get your answer. Okay. Next, move on to the last question for this video. So yes, this must be your question. Now, a train is moving along a straight line with a constant acceleration A. A boy standing in the train throws a ball forward. So let us make a train. This is our train, right? So there is a person in the train. So it is moving with an acceleration A. We don't know about that. A boy standing in the train throws a ball with 10 meter per second at an angle 60 degrees, okay, to the horizontal. So has thrown a ball 60 degrees at an angle 60 degree. Okay. So I'm not, let's not take the height of the ball because it is not given any. It's not given, but let us consider it does not matter actually. So this is 10 meter per second. This is 60 degree. Now what happened? The boy has to move forward by Distance 1.15 meter inside the train to catch the ball back at initial height. Okay, perfect. So yes. So the ball will be moving like this, right? Acceleration of the train we have to find. Now look, the boy has to move forward by a distance 1.15 meter inside the train, right? So inside the train it has to move. Okay, now look, the effect of this acceleration on the ball will be zero. Why? As soon as it moves away from his hand, there will be no acceleration acting on it. So the ball is here, it is moving with 10 meter per second at an angle 60 degree. So the total distance it is going to cover will be r. So let's first find r, right? Because at the same height it is catching. So r will be what? U square sine 2 theta divided by g. So u square will be 100 into sine 2 theta. So sine 60 is 1 sine 120, it will be cos 30, right? And cos 30 is root 3 by 2 into 10, right? So this is 50, this is 5 root 3 meters. Okay, perfect. Now what we have to do next? Yes, what we have to do next? Look, this person, this person has to travel clearly this distance, which is 5 root 3. But with respect to train, it has already traveled 1.5 meter. So let me just write it. X distance traveled by this boy with respect to ground must be how much? 5 root 3, which will be equal to distance traveled by boy with respect to train plus distance traveled by train with respect to ground, right? This we know. So this is 5 root 3 and this we know it is 1.15. Now this we have to find, right? If we got this, then we can find the acceleration. Why? Look, the train is moving with an acceleration a, so we can directly use what? S equal to ut plus half a t square. U is 0. Distance traveled will be xtg equal to half a, and time we will know, right? Perfect. Because time will be what? Time of flight. So first let's find time of flight. So let's find this. Xtg will be 5 root 3. So 5 root 3 is what? It's a bit. So 5 root 3 is 1.7 into 5. I'm using the calculator, minus 1.15. So it will be 7.5 meters. Okay. Yes. So 5 root 3, let me check it again, minus 1.15. 7.5 meter. Okay. Now let's put this in this equation, because after this whole journey the boy is catching, so time will be simply 2u sine theta by g. So 2, how much will be the u? U will be 10, sine 60 degree will be root 3 by 2, okay, divided by g. So g will be 10. So 10 will get cancelled, 2 will get cancelled, time will be simply root 3. Let's put everything in this equation. So what was that? Xtg will be half a t square. Xtg will be 7.5 equals to 1 by 2. Acceleration is how much? Acceleration is how much? We have to find. T square will be 3, right? So it will get cancelled. It will be 2.5 into 2. So 2.5 into 2 will be the acceleration. So acceleration will come out to be 5 meter per second, right? So again, it is an easy question. Simple relative velocity concept, projectile, These two concepts have been there. Okay. So let's end this today's video. In the next video of the kinematics, we will be discussing uh, other questions from projectile and some more. Okay. So total we have discussed 15 questions, right? 15 questions we have discussed. Almost all are easy, like right? Two, three were moderate, one was hard, and other 10, 12 was easy, right? So look, every every questions will be like this. 10, 12 will be on the easy side, 2, 3 will be moderate, and 1 to 2 will be hard, right? So have confidence in yourself and it will be easy. Let's end this video today. Bye bye.